now I can put them up. Okay, it took me ages to convert them, wasn't working. Okay, you will need your calculator here. We're going to do this section all on calculator. So if you haven't got your calculator, can you please make sure you have it handy? All right, we're determining normal probabilities. Now, sometimes we actually want to find probabilities between ranges of either 1, 2, or 3 standard deviations. So we're going to do this on the calculator, okay? So example 3 says, suppose that Z is a standard normal random variable. Now, as soon as it says this, standard normal random variable, that means the mean is a U and the standard deviation is 1, and that's what we're going to use. Part A says find the probability that Z is between -1 and 2.5. Okay, now you might be given X values and you need to convert to the Z, right, the standard form like we did in 16A. Okay, so we've already done that, we're not going to do that, and then you can use your calculator. Anyway, once you convert to the Z's, you can use the normal CDF. So in your calculator, we're going to go to normal CDF. Okay, go to probabilities, normal CDF, and then you're going to put in the -1. Why the -1? Because that's your lowest bound, and it will say lower bound. And then you're going to put in your 2.5 into your upper bound, and then your mean of 0, and your standard deviation of 1, and close and go enter. So I'm going to see if I can bring my calculator up. It is already here. Stop this share, share this. Oh, I've got to come over this side. All right, can you all see the calculator?
No.
Not yet.
No. I'll share it again. Yes or no?
Yep.
Okay.
Yep.
So we're going to go to menu, and remember, right, what I said, we're going to go to the normal CDF. Normal CDF. So I've got to get into my calculator page, menu, distributions. Okay, normal CDF is number 2. Lower bound. I forgot the lower bound number. It was -1. -1, put in the -1. The upper bound, 2.5. The mean is 0, the standard deviation of 1. Press OK. Okay, there you go. You have your probability, 0.8351. Okay, so I'll stop this one and I'll go back to the other one. Normal distribution. Okay, that's how we got that one there. Now, of course, to do the second one, you don't need to go back to there. You can just go to up arrow, select this one here, press enter, and then just change the numbers to 1, because that's the lower bound, because it says greater than 1. And then, of course, if it's greater than 1, our upper bound is infinity. So we're going to put infinity, like I did here. And then 0 and 1 is still 0 and 1. And press enter, and you will get that one. So now you're able to find, you're using the normal CDF, the probability between the Z values. Any questions so far? Okay, let me clear this and move on. Okay, example 4. Now here with example 4, it says, suppose X is normally distributed. Let me close that down. X is normally distributed with the mean of 100 and the standard deviation of 6. Find K such that probability is of X is less than or equal to K equals 0.95. So here we're trying to find this value, okay, when it's, so we're not finding this answer, we're finding inside it. So we're going to do inverse normal, okay, inverse normal. Now, it says to do inverse normal. The 0.95 is that one there, and then it asks us for the mean, which is 100, and the standard deviation, which is 6. So again, I'm going to share that with you, my calculator, so that I can show you how to do it on Calc, even though it's all there. Share, calculator, calculator, calculator. Okay, menu. All right, inverse normal is down.
It's the third one, I believe.
There we go, inverse normal. Okay, so click that one. Now, what was the area? 0.95. And the mean was it 100?
Yes, 100, and the
Standard
variance
deviation?
is 6.
Standard deviation, not variance. Press OK,
Yeah,
and
yep.
you get your pay value. Okay, 109.95. So I'll go back.
Is this whole method on the calculator? So there's
Yes,
no theory way of doing it?
There is, but you will not need to do it unless they ask you to convert from one to the other, which I think is the next exercise. Okay.
Right.
So any questions up to example 4? All right, now that you've seen both the normal and the inverse normal, and you understand why we're doing it, let's have a look at example 5. It says, suppose X is normally distributed with a mean of 100 and a standard deviation of 6. Find C1 and C2 such that the probability of X is between C1 and C2. Okay, has to equal 0.95. So again, we're going to do the inverse normal because we're trying to find these numbers in here, right? These values. So on the graph, if we do our graph and it's there, remember we have 0.95 means 2 standard deviations, 95%. As a decimal, it's 0.95, which means we have 2.5% here. As a decimal, it's 0.025 and 2.5% on this side, and there it is again. Now, our first one is this number over here. So the area that we're looking at is in there, which is 0.025. So there it is there. We're going to find the inverse normal because we want to find our C1, right? There's our area, just like we did before, our area of 0.95. In this case, we have only an area of 0.025. Our mean and our standard deviation. And when we press enter, we get that answer. So that's okay for that one there. For the second one, we have to be careful. The second one is here. There's my C2. Now, a C2, you can do it 2 ways to get your area because the area is always from 0. So the area is all that. So it will be 0.025 plus the 0.95, which is 0.975. Or, of course, you could have just said 1, because the probability adds up to 1, minus this little area in here, which is still 0.975. So there we're going to find that one there. Inverse normal, because we're finding, again, our C value. 0.975, again the mean, and again the standard deviation, and we get our second answer. So we've got our C1 and our C2. Any questions on that one? Okay, so really think about when we do this, what number they give you here, and then think about what those percentages. So you'll need to draw them up, and it might be the 68%. Okay, so that might be C1 and C2. So that means you've got 16% and 16%. Or it might be the 3 standard deviations. Generally, it's the 2. Okay. All right, let me clear that one. Now, symmetry properties play a part in here. So you should know all these symmetric properties. If we're looking at probability of Z being greater than A, then really that's the same as 1 minus probability that Z is less than or equal to A, which is what we did over here. Okay, 1 minus all that. If, now this second one is very, very important, probability that Z is less than negative A, that will be exactly the same as probability that Z is greater than A. Okay, and if Z is between 2 values, one being negative A and the other one being positive A, because they're mirror images, okay, then what we'll have, we can work out 2 rules, 1 minus 2 times the probability of Z being greater than A, because this is what we're going to have. Okay, that part there, and that part there, there's your negative A. Okay, so we can do 1 minus probability of 2 times that, so that gives us that area. Or we can do 1 minus the 2 times that area there, because these two areas are exactly the same. Okay, and that's why we can do times 2. And that's how we can find those. So all these symmetry rules you will need to use. The middle one is probably the most common one. If you have a negative, it's better to do this or these ones, but all of them go very, very handy. Okay, that's 16C. Any questions?